Electrode potentials and cells. How can an electrochemical cell be made? Again, pull up the specification. Just want to show you guys. Just type in the QA of chemistry specification and you just go to the topic. So this one is that. This topic I think it is the hardest paper 1 topic, because the transition metals is not hard, it's memorization, but this one, it is difficult, this topic. So how can electrochemical cell be made? From 2 different metals dipped in salt solutions of the own ions connected by a wire. Electrons flow through the wire from more reactive metals to less. Shows a voltage between 2 half cells. That's what the voltmeter does. Where voltmeter is found in the external circuit, and salt bridge allows ions to flow through. In the zinc/copper electrochemical cell, zinc loses electrons more easily than copper. In the half cell, zinc is oxidized, forming this, releasing electrons into external circuits. Again, all it wants you for this is, it says important conditions, standard electrical potentials, standard electrical listed as a chemical series, electrochemical series, calculate EMF, predict direction. That's pretty simple. Write and apply conventional representation. That was one of the main key skills which you need to practice. Measuring the EMF, and then it's just a practical, which is make simple cells and use them to measure known electrical potentials. So actually, no. This is, so zinc loses electrons more easily than copper. In the half cell, zinc is oxidized from Zn2+, reducing electrons in the external circuit. Other half cell, same number of electrons taken in from external circuits, reducing Cu2% to copper. Reactions happening at each electrode are reversible, and the reduction reactions are always in the forward direction. Electrons are always on the left hand side. Electrode potentials measure how easy a metal is oxidized, how easy a metal loses an electron. A metal that's easy to oxidize is very negative electrode, and a metal that is hard to oxidize is less negative electrode. And you don't actually need to know this, what electrode potential is, how easy a metal is oxidized, but I think it's good for your understanding. How to measure electrode potentials of a half cell. Standard hydrogen electrodes, and standard electrode potentials of voltage measured in standard conditions when the half cells connect to a standard hydrogen electrode. So actually, I've already got standard electrode potential definition, so I can get rid of that. 3 standard conditions, you have to know these. They're relatively simple: 298 Kelvin, 100 kilopascals, concentration 1 mole per DM minus cubed. But the way they asked them in the exam are not as easy as that. They'll give you a diagram, and instead of it saying it'll be 1 mole per DM minus cubed on the left hand electrode, it'll be 0.5, and they'll say state why. State why the student could not use a standard hydrogen electrode because concentration at 1. But you would have to like look at the diagram and then interpret it from there. It's very unlikely they can ask you state 3 conditions, but that's a lot easier. But they can give you those weird kind of questions. If the standard conditions are maintained, then read and voltmeter would be the standard electrical potential half cell, and cell potential is affected by conditions. Electrochemical series, a list of standard electrode potentials for different electrochemical half cells. More negative electrode potentials means right-hand substance is more easily oxidized, left-hand substance is more stable, and more positive electrode potential means left-hand substance is more easily reduced, right-hand substance is more stable. E cell equals E reduced minus E oxidized. Standard electrode potential values. And you should know this by now, E reduced minus E oxidized, so I'm going to get rid of this. No. Yeah, I'm getting rid of that. You should know that, E reduced minus E oxidized. When drawing cells, half cell with more negative potential goes to the left, oxidized forms go in the center of the diagram. Vertical line means in a different phases, and double vertical line means a salt bridge. 3 advantages: cheap and long run, recharge and reuse, last longer. And if I go to this, lithium and mobile phones, laptops, and cars. How to recharge rechargeable batteries, current supplied to force electrons for an opposite direction around circuit reverse reactions, reactions that take place are difficult and impossible to reverse. Chemicals stored in fuel cells, chemicals stored separately outside cell fed with electricity required, alkaline hydrogen oxygen fuel cell power electric vehicles use. How it works: hydrogen oxygen fed into two separate platinum containing electrodes. Electrodes are separated by anion exchange membrane, electrolyzed aqueous alkaline potassium hydroxide solution. Function of this: allows anions and OH minus and water to pass through but not hydrogen oxygen gas, and electrons flow from negative electrode through external circuit to positive electrode. OH minus ions pass through anion exchange membrane to negative electrode. Two advantages of fuel cells: more efficient, only waste products of water, no carbon dioxide and toxic chemicals, don't need to be recharged like batteries, only need hydrogen oxygen. However, we need energy to produce supply of hydrogen oxygen. Hydrogen is flammable. Handled carefully.